students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on, and we have successfully finished the 10 lectures, right? So, in a previous lecture that we are discussing about a dot product or scalar product of the two vectors and the formulas based on the concept. And at the end of the session, we are discussed and we are solved some example problems, right? So, in this lecture, today that we are going to discuss about a vector product or cross product of the two vectors and formulas based on the vector product or cross product. And at the end of the session, same, we are going to discuss some example problems, right? Shall we start the session? Okay. So, my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Okay, right. So, what is the chapter going on? Motion in a plane. Motion in a plane. You know what? I'm a good singer. So this is a class number 11. Okay. All right. So what is the today's topic? And the today's topic is what, ma? Vector product. Vector product or cross product. Vector product or cross product. Right, have a look. What is the meaning of vector product or cross product? Okay, let a bar and b bar are the two vectors, or what, ma? Two vectors, then the cross product, or the vector product of a bar and b bar is given by okay. So have a look. A bar cross b bar is equals to magnitude of a into magnitude of b into sine theta into n cap. So this is the formula for cross product or vector product. What is that? So a bar cross b bar is equals to magnitude of a into magnitude of b into sine theta n cap. So when we are did the dot product of the two vectors, so a bar dot b bar is equals to magnitude of a into magnitude of b into cos theta we got. But so whenever we did a cross product of two vectors, you will get what, ma? So a bar cross b bar is equals to magnitude of a into magnitude of b into sine theta. At the place of cos theta we got, ma? Sine theta and n cap. What is n cap? So where so theta, what is theta? Theta is the angle between a bar and b bar vectors. So n cap, what is n cap? N cap is nothing but the direction of the n cap gives the direction of the resultant of a bar and b bar vectors. So what is n cap, ma? So n cap is the direction of the resultant of the a bar and b bar vectors. Are you getting any doubts? Okay. So the direction of the note, important. The direction of the direction resultant vector, the direction of the resultant is always perpendicular to the plane containing a bar and b bar vectors. Are you getting? So what is the direction of the resultant vector? So the direction of the resultant vector is always perpendicular to the plane containing a bar and b bar vectors. Are you getting any doubts? Okay, I will explain in the form of diagram. Okay, don't get attention. So note number, okay, this is the first note and this is a note number 2. So the second note is important. The cross product or the vector product of product of two vectors gives again a vector again a vector. So whenever you are did the cross product of two vectors, again you will get the resultant is in the form of vector. Are you getting? Let a bar cross b bar is equals to, and just make the cross product of a bar and a b bar vectors, and I got the resultant vector as a c bar. What is c bar? Where c bar is the resultant vector of a bar and a b bar vector. So the cross product gives again a vector. So the cross product or vector product of the two vectors gives what more? Again a vector. Resultant is also in the form of vector. Is it clear? Any doubts? Right. Have a look. How to find the direction of the resultant vector? Have a look. Right. I'm taking a plane. I'm taking a plane. Okay. This is a plane. Let us consider. Okay. So this plane consisting of two vectors. So let us say this is a bar vector and this is a b bar vector. Okay. A bar vector and a b bar vector. I'm just doing the cross product of the two vectors. So a bar cross b bar. A bar cross b bar. Now after doing the cross product of these two vectors, I got a resultant vector c bar. C bar is the resultant vector. Now what we have to find? We have to find the direction of the resultant vector. We have to find what more? Direction of the resultant vector. So to find the direction of the resultant vector, we have two rules. We have how many rules? Two rules. Either you can use first rule or second rule. These two rules gives the direction of the resultant vector. Okay. So the first rule, have a look. So the first rule is a right hand thumb rule. What is that one? Right hand thumb rule. So important. Okay, the meaning of right hand thumb rule, how it gives the direction of the resultant vector. Have a look. According to right hand thumb rule says curl the fingers from curl the fingers from first vector to first vector to second vector through a small angle So just we have to curl our fingers from first vector to second vector. What is the meaning of first vector? What is the meaning of second vector? Have a look. So here we are doing the cross product of a bar and b bar. Okay. So this vector, whatever the vector a bar is there. Okay. Now this is called the first vector. Okay. And this vector is called what? Second vector. This vector is what? Second vector. If you did the cross product of b bar cross a bar. Okay. Now this is called what? First vector. Are you getting? This is called what? Second vector. I hope you understood what is first vector and what is second vector. Okay. So this is first vector and this is second vector. So curl the fingers from first vector to second vector through a small angle. Have a look. This is a bar vector and this is a b bar vector. So small angle. Have a look. These are the two angles are formed by a bar vector and b bar vector. Have a look. So this is a one angle formed by a bar and b bar vector, and this is also one of the angle formed by a bar and b bar vector. So what we have to do? We have to curl our fingers through a small angle. So in between these two angles, what is the smallest angle? So absolutely this is the smallest angle. Now what we have to do? We have to curl our fingers from a bar to b bar vector. That means first vector to second vector through a small angle. So this is a small angle between a bar and the b bar vectors. Okay. Then the direction of thumb gives the direction of resultant vector. Are you getting? So how to find the direction of the resultant vector by using right hand thumb rule? Just we have to curl our fingers from first vector to second vector. Through a small angle. Have a look. So I'm just curling my fingers from a bar to b bar vector through a small angle. then the direction of, thumb, then the direction of the thumb gives the resultant of the A bar and the B bar vectors. Have a look. La 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 la. Have a look. This is the direction of the what? The resultant of A bar cross B bar. Have a look. I will show you. So this is a plane. Okay. In this plane, same plane. I'm taking the same plane here. Okay. Same plane. So in this plane, this is a A bar vector. The green pen is A bar vector, and the black pen is B bar vector. So the two vectors are like this. Now have a look. This is the smallest angle between the two vectors. So this is the smallest angle between the two vectors. Now what we have to do? We have to curl our fingers from A bar to B bar vector. Curl our fingers from A bar to B bar vector through a small angle. Through a small angle. Then the direction of the thumb. Have a look. Observe the thumb. A bar to B bar. Then the direction of the thumb. Then the direction of the thumb gives what? The direction of the resultant vector. That means, so this is what ma? Direction of the thumb. So the direction of the thumb gives what ma? Direction of the resultant vector. So this is the direction of the resultant vector, and always it is perpendicular to the plane containing the two vectors. So have a look. This is the plane containing the two vectors. Okay. So what is the resultant vector we got? The direction of the resultant vector is this. Have a look. So this is the direction of the resultant vector, and this is the plane containing the two vectors. Okay. And this direction of the resultant vector is perpendicular. Have a look. Perpendicular to the plane containing A bar and the B bar vectors. Okay. Any problem? Very good. Are you understood? Okay. So this is the direction of the n cap, and we are rotated like this. Okay. Thumb. Okay. So this is not a leg. This is a hand. This is what? Right hand. Okay. Robo hand. Which hand? Robot hand or alien's hand. Are you understood how to find the direction of the resultant vector? Just curl the fingers from A bar to B bar vector through a small angle. Okay. Then the direction of the thumb gives the direction of the resultant vector. In this case, so this is the direction of the resultant vector, and the direction of the resultant vector is always perpendicular to the plane containing the A bar and B bar vectors. Are you getting? Any doubts? Okay. Just pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. So the second rule is right hand screw rule. What is that? Right hand screw rule. Okay. So what is the meaning of right hand screw rule? How it gives the direction of the resultant vector? Have a look. Same. Place the screw. Place the screw at point where the two vectors are coincide. So have a look. At this point, the two vectors are coincide. What we have to do? We have to place the screw at this point. Now rotate. Rotate the screw. Rotate the screw from first vector to second vector through a small angle. Okay, we have to rotate the screw from first vector to second vector through a small angle. Okay. Now the direction of the advancement of the screw gives the direction of resultant vector. Are you getting me? Any doubts? Okay, have a look. What we have to do? We have to place the screw at the point where the two vectors are coincides. It is clear that at this point the two vectors are coincide. Now what we have to do? We have to rotate the screw from first vector to second vector. Through the small angle. I'm just rotating the screw from first vector to second vector. Have a look. A bar to B bar. Have a look. The screw is advancing from outward the plane of the board. Outward from the plane of the board. Have a look. So this is a plane. So here we have the two vectors. Okay. Here we have the two vectors. Now what we have to do, this is a bar vector and this is a B bar vector. Rotate the screw from A bar to B bar vector through a small angle. Just I am rotating the screw. So what happened? The screw is advancing outward from the plane. It is moving outward from the plane. Have a look. Whenever we are did the right hand thumb rule. So whenever we are rotating our fingers from A bar to B bar vector, the direction of the resultant vector is perpendicular to the plane containing A bar and B bar vector. Same thing. Whenever we are rotate the screw from A bar to B bar vector, what happened? It is advancing perpendicular to the plane. It is advancing perpendicular to the plane. Now the direction of the resultant vector is perpendicular to the plane containing A bar and B bar vectors. Have a look. Just place the screw and rotate it from A bar to B bar vector. So it is comes outward from the plane. It is comes outward from the plane. Now what is the direction of the resultant vector? In upward direction. Are you getting me? Any doubts? Right. Now what is this? This is the direction of the resultant vector. So A bar cross B bar is equals to C bar. Okay. So this is what the direction of the resultant vector. Is it clear? Any doubts? Just pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So have a look. The seventh formula. So the seventh formula is, if n cap is a unit vector, n cap is a unit vector, and it is perpendicular to both A bar and B bar vectors. It is perpendicular to both A bar and B bar vectors. Then the unit vector n cap is given by, n cap is equals to plus or minus A bar cross B bar divided by magnitude of A bar cross B bar. Magnitude of A bar cross B bar. Okay. So this is a formula for unit vector when that unit vector is perpendicular to both A bar and B bar vectors. Is it clear? Right. So let us see the next formula, eighth formula. If the magnitude of a vector, if the magnitude of a vector, that is C. I am taking the magnitude of vector is C, and it is perpendicular to both A bar and B bar vectors. Then C bar as, then we can write the vector C bar as, C bar is equals to plus or minus magnitude of this vector into A bar cross B bar divided by magnitude of A bar cross B bar. Okay, are you getting? So based on these formulas we have problems. Okay, right. So ninth one, if A bar and B bar are the two parallel vectors, and they are related as, so A bar is equals to K into B bar. So if A bar and B bar are the two parallel vectors and they are related as A bar is equals to K into B bar. What is K? Where K is nothing but it is a scalar quantity. Okay, now it is a scalar quantity. So as we know that, so the general form of A bar vector, what is that? Ax I cap plus Ay j cap plus Az k cap, and the general form of B bar vector. So what is that? Bx I cap plus By j cap plus Bz k cap. Okay, right. Then we can write the formula for this condition is Ax by Bx, that is equal to Ay by By is equals to Az by Bz is equals to K. So when the two vectors are parallel to each other and then they are related with a scalar like this, then the resultant vector is given by what? ax by bx is equals to ay by by is equals to az by bz is equals to that scalar quantity. Okay, right. So the next one, 10th one, if a bar and b bar are a bar and b bar vectors are anti-parallel to each other, are anti-parallel to each other, and they are related as a bar is equals to minus kb bar, then they are related as a bar is equals to minus kb bar, then the resultant vector is given by ax by bx is equals to ay by by is equals to az by bz is equals to minus k is equals to how much more? Minus k. You have to remember these formulas. Okay, right. So the 11th one. Okay, so if a bar and b bar are the two adjacent sides of a are the two adjacent sides of a triangle are the two adjacent sides of a triangle, then the area of triangle then the area of triangle is given by then the area of the triangle is given by that is equals to magnitude of a bar cross b bar, magnitude of a bar cross b bar. So when if a bar and b bar are the two vectors and they are taken as the adjacent sides of a triangle, then the area of triangle is given by magnitude of a bar cross b bar. Are you getting? Okay. So the 12th one, if a bar and b bar vectors are taken as the adjacent sides of a the adjacent sides of a parallelogram, adjacent sides of a parallelogram, then its area is equals to the area of the parallelogram when the two vectors a bar and b bar are taken as its adjacent sides, then its area is equals to again magnitude of a bar cross b bar. Are you getting? Any doubts? Okay. So let us see the 13th one. If a bar and b bar vectors are represents the diagonals of a the diagonals of a parallelogram, then its area. So whenever the two vectors a bar and b bar are taken as the diagonals of a parallelogram, then the area of the parallelogram is given by half into magnitude of a bar cross b bar, half into magnitude of a bar cross b bar. Okay, are you getting? Any doubts? Okay, so just pause the video and write the formulas. Okay, 3 2 1 go. Right, have a look the 13th formula. How many formulas are there, sir? Okay, so please learn. For you only, I'm just giving all these formulas. Okay, so at any corner they are asked any question, we are ready to do the solution. Okay, that's why I'm just giving all these formulas for you. Okay, right. So the 13th formula, the cross product of a vector, the cross product of a vector itself, the cross product of a vector itself gives a null vector. This gives a null vector. That means, right, let us consider there is a vector a bar and the cross product of a vector itself, the cross product of a vector itself, that is a bar cross a bar, is equals to how much more? Is gives a null vector, that is 0 bar. That means, have a look. So in general, a bar cross a bar is equals to what? Magnitude of a into sine theta. So have a look, what is the angle between a and a? Those two are parallel to each other. A and a means what more? Parallel vectors. What is the angle between them? 0 degrees. So theta is equals to 0 degrees. Sine 0, 0. 0 into something? 0. So the cross product of a vector itself gives what? Null vector. Are you getting? Any doubts? Right. So the next one, the laws of The loss of a vector product. Loss of a vector product. Okay. So the first law, the cross product, the cross product does not does not obeys the commutative law. Obeys the commutative law. That means A bar cross B bar, A bar cross B bar does not equals to B bar cross A bar. Are you getting? A bar cross B bar does not equals to B bar cross A bar. Have a look. Here is a vector A bar. Okay. And here we have a vector B bar. So what we are doing? We are doing A bar cross B bar. A bar cross B bar. So first vector to second vector, the angle is 90 degrees or whatever it is. Let us consider theta. Theta be the angle between two vectors. A bar cross B bar. A bar cross B bar. Have a look. The direction of the resultant vector A bar cross B bar is into the plane of the board. Have a look. A bar cross B bar. So the direction is into the plane of the board. This means what? The direction of the C bar is what? C bar is the resultant vector and its direction is into the plane of the board. Have a look. A bar cross B bar into the plane of the board. If you made B bar cross A bar, what is this? This is A bar cross B bar. If you make the cross product of B bar cross A bar, so this is B and this is what? A. So the B bar cross A bar from B to A. B bar cross A bar, B bar cross A bar, B bar cross A bar. So the direction of the C bar vector, resultant vector, is what now? Outward from the plane of the board. Outward to the plane of the board. Here, the direction of the C bar vector into the plane of the board. So that's why A bar cross B bar does not equals to B bar cross A bar because the direction of the resultant vector will be changes. If the direction of the resultant vector is changes, then the sign of the resultant vector will be changes. Right. So the second one, the cross product of two vectors, the cross product of two vectors obeys. Here it does not obey commutative law, but it obeys anti-commutative law. Anti-commutative law. That means A bar cross B bar is equals to negative sign of B bar cross A bar. Negative sign of B bar cross A bar. It obeys anti-commutative law. Okay. Are you getting any doubts? Let us see the third one. So the third one is vector product obeys the distributive law. Obeys distributive law. Okay, vector product obeys the distributive law. That means A bar cross B bar plus C bar is equals to A bar cross B bar plus A bar cross C bar. A bar cross B bar plus A bar cross C bar. Are you getting any doubts? So the vector product obeys distributive law. It does not obey commutative law, but it obeys anti-commutative law. Because why it is not obeys commutative law? The direction of the resultant vector will be changes. So that's why it does not obey commutative law, but it obeys anti-commutative law. Because in front of B bar cross A bar we are placed minus. Have a look. At this time A bar cross B bar into the plane of the board. Resultant is into the plane of the board. Let us consider the resultant is a plus because it is into the plane of the board. So B bar cross A bar. B bar cross A bar is outward from the plane of the board. Let us consider this is a negative sign because it is opposite direction to this. Have a look. B bar cross A bar value we got negative. In front of this we are again placed a negative. Again we are placed a negative. Minus into minus plus. So A bar cross B bar is plus. B bar cross A bar is also plus. Then we are taking an anti-commutative law. Minus into minus plus. Are you getting any doubts? Right. So pause the video and write the notes. Pause the video and write the notes. over all the formulas are completed. Okay, right, pause the video and write the notes. 3, 2, 1, go. Let's we solve some example problems. Okay, right. Right. So I'm just bring the two examples. Have a look. So what is the first example? If f bar is equals to 4 I cap minus 10 j cap and r bar is equals to 5 I cap minus 3 j cap. They are given f vector and r vector, force vector and position vector. So what they are asking? They are asking to find the torque. Okay, na torque. So already in examples I told you the formula for torque. So what is the torque? So torque tau is equals to r bar cross f bar. So this is the formula. Now we have to make the cross product of r bar and the f bar vector. Have a look how to do the cross product in a simple way. I will explain. Have a look. So what is the force vector they are given? F bar is equals to 4 I cap minus 10 j cap. 4 I cap minus 10 j cap. And taking the k cap vector, that is a 0 k cap. They are not given k cap, just I am taking 0 into k cap. 0 into k cap means 0. So 4 I cap minus 10 j cap plus 0 k cap. They are not given, just I am taking 0 k cap. 0 into something 0. Any problem? Okay. So r bar vector. R bar is equals to 5 I cap. R bar is equals to 5 I cap minus 3 j cap. K cap vector they are not given. I am just taking 0 k cap. 0 into something 0. So now what we have to do? For torque we have to make the cross product of this vector into this vector. Then torque tau is equals to magnitude of, in a simple way. In a simple way we have to make the cross product. Have a look. So the magnitude of, let us take I cap, j cap and k cap. I cap, j cap and k cap. So this is a plus term. So this middle j cap is a negative term and this is a plus k cap. Plus, minus, plus. Okay, right. What is the first vector? R bar. R bar is our first vector. So R bar is here. So what is the coefficient of I cap? 5. Just write under I cap. What is the coefficient of j cap? Minus 3. Just write under j cap minus 3. What is the coefficient of k cap? 0. Are you getting any doubts? Okay. So next, what is the second vector? Force. So just take a coefficient of I cap. Coefficient of j cap is minus 10. Coefficient of k cap is 0. Now we have to find the resultant torque vector. Have a look. Torque tau is equals to, here we have I cap. Just take I cap into, leave this row and column. Okay, now remove this column and the row. So minus 3 into 0. Minus 3 into 0. 0. Right. Let us see solve the second example. Okay, have a look. What is that? So find the unit vector perpendicular to the both vectors. So 2 I cap plus 3 j cap plus 5 k cap and I cap minus j cap plus 2 k cap. So what they are asking? They are given two vectors solution. So have a look. This is the first vector. First vector. I am just taking this vector as a bar, that is equals to 2 I cap plus 3 j cap plus k cap, and this vector as a b bar vector, that is equals to I cap minus j cap plus 2 k cap. So what they are asking? They are asking to find the unit vector which is perpendicular to the both vectors a bar and a b bar. In a formulas, I told you that the seventh formula we have, whenever the unit vector is perpendicular to the two vectors a bar and b bar, so then the unit vector is given by n cap is equals to plus or minus a bar cross b bar divided by magnitude of a bar cross b bar. Magnitude of a bar cross b bar. So what we have to do? Just we have to find the cross product of these two vectors, and after that the magnitude of the cross product of the two vectors. Then we have to substitute here. Then we will get the answer. Are you getting? Just pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. Right. I'm just going to find the cross product of a bar and b bar vectors. So what we have to do? We have to take a mod. So this is what I cap, this is what j cap, and this is k cap. So this has a negative sign, positive sign, and positive sign. Next, what is our first vector? A bar. Here a bar vector is there. What is the coefficient of I cap? 2. What is the coefficient of j cap? 3. What is the coefficient of k cap? 1. Next we have a b bar vector. What is the coefficient of I cap vector? 1. What is the coefficient of vector j cap? Minus 1. Coefficient of k cap vector? 2. So now a bar cross b bar is equals to, that is equals to So have a look. What is the first one? I cap. First one is I cap. So what we have to do? Just we have to remove this column and row. Then 3 to the 6. When we are moving in upward direction, we have to take a negative sign into minus 1 1 the minus 1. Okay, minus 1 into 1 minus 1. Next we have minus j cap. Just leave this row and the column. So have a look. 2 to the 4. Whenever we are calculating downward to upward direction, we have to take minus 1 1 the 1 plus k cap. Are you getting one? So remove this row and column. 2 into minus 1 minus 2. Whenever we are moving from downward to upward, we have to take negative sign. 1 3 the 3. That's it. Okay, likewise you have to make the cross product. Okay, right. Right, have a look. I cap into 6 minus into minus plus 1 minus j cap into 4 minus 1 3 plus k cap into minus 2 minus 3 minus 5, that is equals to 6 plus 1 7 I cap 3 into j cap minus 3 j cap plus minus into plus minus 5 into k cap 5 k cap. Okay, so we got a bar cross b bar is equals to 7 I cap minus 3 j cap minus 5 k cap. So we got a bar cross b bar value. Next what we have to find? We have to find the magnitude of a bar cross b bar vector. So the magnitude of a bar cross b bar is equals to, so whenever we are finding the magnitude, just we have to take the square root and we have to square the coefficient of I cap, j cap and k cap. So 7 square plus minus 3 whole square is nothing but 3 square plus 5 square, that is equals to under root of 7 7s are 49, 3 3s are 9, 5 5s are 25. Okay, 49 plus 9 58, 58 plus 5 58, 59 63, 63 plus 20 root over 83. Are you getting? 9 9 18 23. 4 plus 4 83. Okay, so just substitute these values. Let us say this is equation number 2, this is equation number 1. Substitute 1 and 2 in n cap, in n cap. So we got a bar plus b bar is equals to how much, ma? 7 I cap minus 3 j cap minus 5 k cap, minus 5 k cap divided by magnitude is how much? Root 83, and this is our answer. Okay, so likewise you have to find the given unit vector which is perpendicular to the two vectors. What is the formula, ma? N cap is equals to plus or minus a bar cross b bar by magnitude of a bar cross b bar. Okay, any problem? Right, I hope that you are learned how to do the cross product of given two vectors. Okay, right. Just pause the video and write the solutions. 3 2 1 go. Right. So let us see the example number 3. So what is the example number 3 they are given? The diagonals of a parallelogram are given by the vectors 3 I cap plus j cap plus 2 k cap and I cap minus 3 j cap plus 4 k cap. They are given two vectors and the two vectors are the diagonals of a parallelogram. What they are asking? They are asking to find the area of the parallelogram. I told you the formula. So what is the formula? Let us consider this is a bar vector. A bar is equals to 3 I cap plus j cap plus 2 k cap, and a b bar vector is equals to I cap minus 3 j cap plus 4 k cap. These are the two vectors they are given. What they are asking, these two vectors are the diagonals of the parallelogram and we have to find area of the parallelogram. We have the formula. What is that? So whenever these two vectors are diagonals of a parallelogram, then the area of the parallelogram is given by area is equals to half into magnitude of a bar cross b bar. That's it. Okay, just find out a bar cross b bar. After that, find the magnitude of its a bar cross b bar. Then just substitute here. You will get the answer. Pause the video and try the solution. Pause the video and try the solution. 3 2 1 go. I'm going to solve the solution. Have a look. A bar cross b bar. So that is equals to, so I cap, j cap, k cap. This is a plus, minus, plus. So first vector is a bar. The coefficient of I cap is 3 1 2. Next vector is b bar 1 minus 3 4. Okay, right? So just we have to make the multiplication. So I cap into 4 1 are 4. If we are multiplying in upward direction, we have to take negative sign. Minus of 3 to the 6. Here minus is there. Minus 6. Minus. Second one is minus j cap. So just remove this row and column. 3 4 the 12. If you are moving in upward direction, we have to take negative sign. 1 2 the 2 plus k cap into 3 3 are 9 minus 9 because minus is there. When we are multiplying in upward direction, we have to take minus 1 1 are 1. So that is equals to I cap into minus plus 4 plus 6 10 minus j cap 12 minus 2 10 plus minus 1 minus 9 minus 10 minus into plus minus minus 10 k cap. Okay, so next what we have to find, this is what the value of a bar cross b bar. Next we have to find the value of a bar cross b bar, magnitude. So magnitude of a bar cross b bar, that is equals to under root of 10 square plus 10 square plus 10 square. So 10 square plus 10 square plus 10 square, 100 plus 100 plus 100, root over 300. It can be written as root 3 into 100, root 3 into 100. If 100 comes out from the root, it becomes 10 root 3. Just substitute this value here. So the area of parallelogram is equals to half into magnitude of a cross b. So that is equals to half into, what is the value of magnitude of a cross b? 10 root 3. Okay, so 2 ones are 2 5s are, that is equals to 5 root 3. So this is the area of the parallelogram. Are you getting any doubt? Simple problem. Okay, just you have to remember the formula. Okay, right. Let us see the fourth one solution. So what they are asking, they are given one relation. What is that? Root 3 into a bar cross b bar magnitude is equals to a bar dot b bar. So this is a cross product and that is a dot product. Vector product, scalar product. What they are asking? They are asking the angle between a bar and b bar vectors. The angle between a bar and b bar vectors. So just pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. So I'm just going to solve the solution. Here root 3 is there. Magnitude of a bar cross b bar. Magnitude of a bar cross b bar is given by, in general, what is the meaning of a bar cross b bar? So magnitude of a into magnitude of b into sine theta. Magnitude of a into magnitude of b into sine theta. Modulus. Modulus means plus or minus. Modulus means mod. Either it is plus or negative sign, we don't know. So that is equals to a bar dot b bar. What is the value of a bar dot b bar? Dot product magnitude of a into magnitude of b into cos theta. In both sides, magnitude of a get cancelled out, magnitude of b get cancelled out, and here we got plus or minus root 3 sin theta. Are you getting ma? Modulus means either it is plus or it is minus, plus or minus. Magnitude of a, magnitude of b, sin theta. Here root 3 is there. Root 3 sin theta plus or minus. That is equals to cos theta. Okay. So just bring this cos theta to this side. It becomes sin theta divided by cos theta. That is equals to plus or minus. If root 3 went to that side, it becomes 1 by root 3. Okay. So sin theta by cos theta, it becomes tan theta is equals to plus or minus 1 by root 3. So what is the value of 1 by root 3 in terms of tan? In terms of tan, the value of 1 by root 3 is given by tan 30 degrees. Tan 30 degrees. Here we have plus or minus. Here we have plus or minus. So if you made tan 30, it gives root 3 by t. Either it is theta is equals to 30 degrees when you are taken plus 1 by root 3. Either it is 150 degrees. Either it is 150 degrees when you are taken minus 1 by root 3. Are you getting? Here we have plus or minus 1 by root 3. If you take tan 30 degrees, tan get cancelled, theta is equals to 30 degrees. If tan 30 gives 1 by root 3. If you take minus 1 by root 3, minus 1 by root 3. So tan 150 value gives what more? Minus 1 by root 3. So tan get cancelled out and again theta is equals to 150 degrees. That means either theta is equals to 30 degrees or theta is equals to 150 degrees. Is it clear? Any doubts? Right. Just pause the video and write the solution. Pause the video and write the solution. 3, 2, 1, go. Right. So this is the end of the today's lecture. We have discussed a lot of things in this session. So each and every formula is important because we don't know from which corner they are asking the question. So that's why please learn all the formulas and you can do the problems easily. Okay. Right. So this is Rakesh Kanganti signing off. We will meet on the next lecture. Until then, stay tuned. Jai Hind.